So oxidation is loss of electron and reduction is gain of electrons. All right, let me give you a few examples of that. If I have sodium and it is losing electron, examples of oxidation, and I'm showing you examples of oxidation. Sodium is getting oxidized to Na plus by the loss of one electron. Similarly, if I have potassium and it is getting converted in K plus by the loss of one electron, that means oxidation of potassium is happening. Here, oxidation of sodium is happening. Similarly, if I have aluminium, aluminium loses 3 electrons to get converted in its common oxidation state, that is plus 3. So, aluminium is getting oxidized into Al plus 3. So these are few examples where oxidation is happening. Similarly, now I will show you few examples where reduction is happening. Example, chlorine gains electron to get converted into Cl minus. This means chlorine is getting reduced to chloride ion. Similarly, fluorine gains electron to get converted into F minus. So fluorine is getting reduced to F minus. So addition of electron is basically reduction. All right. If I take an example where sodium combines with chlorine to form NaCl, so what is happening out here? Sodium is in oxidation state 0, chlorine is in oxidation state 0, and in NaCl, Na plus 1 and Cl is in minus 1. So sodium is losing electron. So oxidation is happening for sodium. Simultaneously, for chlorine, it is gaining electrons, so reduction of chlorine is happening. So both of these are happening simultaneously. For that reason, we call this reaction as a redox reaction. Reduction and oxidation is happening at the same time. So we call this reaction as a redox reaction, right? Similarly, I'll take another example where we have Cu plus 2 and zinc in solid form and Cu plus 2 in aqueous form. Right now, what will happen is in the process, in the reaction, Cu will gain electron and it will convert into copper solid, and zinc will lose electron and it will convert into zinc ions, Zn plus 2 ions. All right. So what has happened is copper 2 plus has gained the electron. So Cu plus 2 has reduced into copper. So reduction has happened for copper 2 plus ions. And zinc has lost electrons to get converted into zinc plus 2. So oxidation is happening for zinc and reduction is happening for copper. All right. So this is another example for redox reaction. The species which is getting oxidized, the species which is undergoing oxidation acts as reducing agent for another species. I'll repeat, a species which is getting oxidized itself is acting like a reducing agent for another. For example, here zinc is getting oxidized, so it is acting like a reducing agent for copper 2 plus. If zinc has not lost electron, then from where Cu plus 2 will gain electron. So zinc is helping copper 2 plus in reduction. So zinc is reducing agent for copper 2 plus. Similarly, copper 2 plus is gaining electron. That means it is itself getting reduced. So it is helping zinc in getting oxidized. So copper 2 plus acts as a oxidizing agent for zinc. So just remember, it is exactly opposite. It is exactly opposite what they themselves are doing. For example, Cu plus 2 is undergoing reduction. So it is oxidizing agent for zinc. And zinc itself is getting oxidized. So zinc is showing oxidation. So it is acting as a reducing agent for Cu2 plus. So agent is basically for the species in front. So Cu plus 2 is oxidizing agent for zinc and Zn is reducing agent for Cu2 plus. So agent is basically the effect of a particular species on the another species. So zinc is getting oxidized So it is helping Cu2 plus in reduction. So it is reducing agent for Cu2 plus. Similarly, Cu2 plus is undergoing reduction by gaining electrons. Cu2 plus is undergoing reduction. So it is helping zinc in getting oxidized. So for zinc, Cu2 plus is oxidizing agent. Alright. So just remember, if a particular species is undergoing oxidation, so it is a reducing agent for another species. If something is getting reduced itself, then it is acting like a oxidizing agent for another. So just check out whether a particular species or ion is undergoing oxidation, call that as reducing agent. If a species is itself undergoing reduction, call that as oxidizing agent. So it is opposite of what they are undergoing. If they are undergoing reduction, oxidizing agent. If they are undergoing reduction, they are reducing agent. I'll repeat it again. You might get overwhelmed by so many things happening simultaneously. Just remember, oxidation, a species having undergoing oxidation is reducing agent. A species undergoing reduction is oxidizing agent. Cu2 plus reduction, so it is oxidizing agent. Zinc oxidation, so it is reducing agent. I hope you must have understood what oxidizing agent and reducing agent and how to figure out which is oxidizing agent and which is reducing agent. Now, how oxidation number is calculated? Oxidation number calculation needs you to have few informations which I'll be telling you now. Oxidation number of elements in their natural form. Example, oxidation number of fluorine in F2, chlorine in Cl2, hydrogen in H2 will always be 0. Alright. Oxidation number of group 1 metals is +1. Oxidation number of group 2 metals is +2. Always. Alright. Hydrogen has oxidation number of +1 or -1. If hydrogen is attached to a non-metal, hydrogen has oxidation number +1. If hydrogen is attached to a metal, hydrogen has oxidation number -1. Halogens commonly show -1, but that can change as well. The range for halogens to have oxidation number is -1 to +7. Anything they can have in between, but common oxidation state is -1. Similarly, group 15 elements, example nitrogen, phosphorus, they can have oxidation state anywhere between -3 to +5. And group 16 elements, oxygen, sulfur, sulfur can have oxidation state anywhere between -2 to +6. So for that we have certain rules which you will be studying later. Alright. So this is it for now. We'll continue in further topics. Okay. Bye.